Hi, thanks for inviting me. So I'm going to talk about submarine swaps and Lightning Loop, which is something that I work on at Lightning Labs. So something that's pretty important to understand about Lightning is that it is a flow network. So once you set up your channels and you're in a network of channels with other people, the balances can only shift along flow properties of the network. So like if I spin my channel entirely down, then I can no longer send to somebody else. And also if I spin my channel down in one direction, even if I have balance in another direction, I can't use it to apply to the other direction, which is super different from the UTXO model that the blockchain uses. The blockchain uses a broadcast system. So in Lightning, we get these like great scaling characteristics because of this flow model that only the people like involved with the payment or maybe in the middle of the payment need to really know about it. So that scales great. You know, you can load up tons and tons of people, and as long as you're just bothering your section of the network, you're not impacting anybody else. But with the UTXO model that the blockchain uses, you're bothering everybody in the world, but you're also getting this great property that you can send to anybody in the world. You don't need any flow with them. So we actually, even though we have like this one concept Bitcoin, we actually have like multiple different networks where settlement can happen. And each have kind of like pros and cons. So a submarine swap is something that I thought about a while ago as a way to kind of deal with these pros and cons. So what happens if I've got some funds on the chain and I want to do stuff that the chain can do, but I also want to interact with the Lightning Network? Or what happens if I'm on the Lightning Network, but I'm limited, those flow limitations are really getting to me, like I need to escape that. In that case, I want to use the advantages of the chain. So in order to make that work, I kind of just deconstructed what an HTLC is. The HTLC is like the building block of the Lightning Network itself. And in an HTLC, this is kind of like a classic version of an HTLC. You have two locking conditions. You have the locking condition, which is a hash, and you have the locking condition, which is time. So those are the H and T in HTLC. So if you're familiar with Bitcoin script, these are like kind of Bitcoin opcodes and kind of just like a rough representation of how the script like executes. So what the first line is saying is, I should fix this, but the first line is saying like, if I see a pre-image, so like the secret part of a hash, then I'm going to go to condition 1. And if this hash doesn't match, then I'm going to go to condition 2. And so what condition 1 says is, if that pre-image, if that secret value match that hash, then Alice can kind of control these funds. And otherwise, we're going to do a check on the time. So we're going to do a check on the lock time of the transaction to see if it's at a current, height that's where it should be. And then, even though the hash is incorrect, Bob will get control over those funds. And this is like a stack-based language. So what's really happening is like the pub key is getting pushed onto the stack, and we're falling out of these conditions. And then the final code is to check the signature. So whoever provides the signature and also pass these first checks will be able to send the funds around. Okay, so some things that are not super intuitive about HTLCs are like how do they execute? So here's the execution flow of how this actually goes. So in the successful case, we have the secret is revealed. And Alice's signature is presented. But one thing to notice is that the success case is the entirety of the time. So it's not an or situation. So even you can see that there's some delay for the timeout to start executing. But even during the timeout period, both sides can actually execute. Both sides now share control of the funds. So one thing is if you are like deploying this type of contract and if you're using Lightning Network, you actually are using this contract already. One thing to bear in mind is that the fee market can play a role in this, because what happens if you want to execute the success case, and you think, oh, I have a lot of time before the timeout is going to start executing, and you put in your transaction with a success case well before the timeout, but you put in your transaction at a very low fee rate, and maybe there's a fee spike. What we have is like a race. We have if you are not attentive to that fee, if you're not bumping that fee somehow, then you can get into the danger zone, which is the timeout zone, and the other party can start to take control. And especially in the Lightning Network, once you reveal the pre-image, which is kind of like a secret information, people along the route can start taking those funds. So you need to be pretty careful. Even though a submarine swap is designed to be like minimal trust, you need to execute it properly. So you need to give yourself plenty of time, and you need to consider that in the case of a fee rise, you're going to need to bump it up. Yeah, what's plenty of time?
Minutes? Half an hour?
That's something that's pretty interesting to think about, especially like if you're doing submarine swaps across different networks. You have time that's running at one speed on one network and time that's running on another speed, because these are in blocks. And it really depends on like how you define the contract. So you could define the contract to give yourself a huge amount of time, but then if things go wrong, you're also going to have to wait a huge amount of time to do the refund part. So it's really something that needs to be like part of an overall solution for yourself. Okay, so since I came out with the submarine swaps, I made like submarineswaps.org, and I published some information on the idea. Some people have started to adapt it to their own use cases. And I saw Moon Wallet and Breeze Wallet have adapted it into their wallets, and at Lightning Labs, we're working on including it into the Lightning app that we're working on. And one really interesting thing or cool thing about submarine swaps is that they're very adaptable, because they're very simplistic. It's just those two clauses. You don't have to fit within the Lightning structures of how contracts should be developed. So one thing that I've seen in the wild is that so one thing that I actually changed in my own script is I added this hash 160. That allows you to create your private keys in Bitcoin Core, or a wallet that's like friendly to Bitcoin Core. And then Bitcoin Core has like a dump private key that makes it really easy to, if you're using some other software and you don't want to have your private keys, if you want to just have the standard flow of private keys, you'll be able to dump them out. And Bitcoin Core doesn't otherwise have a way to get at your private keys. So the hash 160 can kind of make it like friendly towards the kind of keys that Bitcoin Core knows about. Size is also something to think about. I showed you that contract before, but there's a potential vulnerability that you need to think about, which is what happens if that secret, although it matches up to a hash that I expect, but maybe it's some crazy huge secret value, and I didn't expect it to be that size. In some cases, you don't actually need this op size, because so for example, my implementation, I omitted it because it's checked already on the Lightning side. So when I make a Lightning payment out, all Lightning HTLCs already include this op size check. But in certain cases, so like in Lightning Labs, we have a implementation of submarine swaps that was created by Yoast from scratch, and it goes in the other direction. Although it goes in both directions now, it started in the other direction from my implementation. And in that case, op size became more of like a safety precaution to make sure that the secret that's being exchanged is of a consistent size that we expect. OpCSV is something that I've seen people use. I'm not sure which wallet, one of the wallets included it. I'm not sure why you would use this. So CLTV is used pretty consistently for HTLCs in Lightning, because it makes it just easy to reason about when are things going to be finished. Otherwise, and they give you kind of pressure to go to the chain and actually execute the contract. And CSV really, it becomes basically like a CLTV as soon as it hits the chain. And hopefully these swaps are going to the chain. Another interesting thing that I haven't seen used in the wild, but I think could be used, is that you can set up the refund path of the submarine swap to go to an unconventional, well, a somewhat conventional, but less conventional wallet, which is controlled by multiple keys. So like if you have a 2 of 3 wallet, you could actually do a swap to pay to a Lightning payment request. And then you could do it in a way where if the swap doesn't go correctly, it refunds back to the 2 of 3 controlling setup that you already maybe were spending from. So submarine swaps can be compatible with a wide variety of wallets. Okay, so when I first started working on submarine swaps, I actually was thinking about it in the context of altcoin swaps. Like altcoins were super hot, and I was thinking the demand is really in altcoins. I mean, there was a lot of interesting use cases though for Bitcoin. And the other thing that I was thinking about is that we have that flow problem, and we have the potential solution, which is to use a non-flow network, like a UTXO network. So I was thinking, what if we used an altcoins UTXO network for this purpose? So either a sidechain, so we could fix balance problems with a sidechain, or potentially we could go to a different chain, and if the chain fees were too high, they would override the problems of switching between different currencies. So maybe I have a switching cost of 1% to go to Litecoin, but the chain fees on Litecoin are so good that I'm fine to switch over and switch back as long as it makes sense from a cost perspective. But at the moment, and with Lightning Loop, we only support one currency, and that's Bitcoin. And there's already tons of use cases that make it very compelling for us to include it in Lightning in our app. So we have kind of like this nomenclature about swaps in terms of directionality, where we say it's an in swap if it's going into the Lightning Network, and it's an out swap if it's going out of the Lightning Network. In swap is what I originally made, and the idea is, what if I've run down the liquidity in my wallet? I've gone on a spending spree, and I've bought so much stuff that now I need to go to the exchange and bring my wallet, fill up my wallet again with money. So there's two possible ways you can go about this. One way is you can add a new channel. Actually, you can just put funds on your regular wallet, and this is how you can do it on the existing Lightning app wallet and lots of Lightning wallets, and you'll make a new channel. The problem with making a new channel is you're increasing the burden on your channel partner. So what's the situation from your peer's perspective? You are spending down your channel, especially if you're on your phone. You're spending down your channel, then you're making a new channel. Spend down that new channel, make a new channel. And from your peer's perspective, now more and more of their funds are getting locked up with you. So it's possible that you're paying enough in routing fees that it's worth it to them. They have enough money that they can just kind of provide for that liquidity. But if you use a submarine swap, you can reuse the same existing channel, and instead of changing how much capital needs to be devoted to this relationship, you just reset the scenario through the swap provider so that the person's channel is full again, and they can spend again maybe for months and months. And if we look at the metrics on the Lightning Network, the average channel is already averaging months of use, and we could easily see a full year of use. And hopefully, we can make channels as long-lasting as possible, because in order to get savings, we want to aggregate as much transactions as possible into one channel. Another way that you can use submarine swaps that I think is pretty cool, and that's something that I was thinking about when I first did Bitcoin to Bitcoin swaps in submarineswaps.org, is that you can take your cold wallet or your non-Lightning wallet, and you can buy those cool things that are available on Lightning. So maybe there's some kind of fun game or something that you want to play, and you're not really interested in like Lightning spending all the time. You can take your normal like Trezor and you can spend to a normal address, normal pay to script hash address, and it's a non-custodial operation. You still have this refund scenario, and then you can go to stores that accept Lightning and you can pay them. That could even work like with something like Bitrefill. So Bitrefill will give you a 2% discount if you play with Lightning. So if you had a swap provider who charged you 1%, then and the chain fees were low for maybe a large purchase, it could actually be advantageous to you to make this type of a swap. I actually think maybe I made a mistake when I was working on Submarine Swaps, because it turned out that the bigger use case for swaps is the other way. So I have Lightning funds and I want to get them out. I want to get them out of my channel. And the biggest reason that people want to get their funds out of their channels is because of a capital problem that we have in Lightning. And the capital problem is there's limited amount of Bitcoins, but in order for you to receive funds, somebody needs to commit their Bitcoins in your direction. And they could select anybody in the network to commit their funds in their direction, but they only have a limited amount of Bitcoins. So what the Submarine Swap does in this case is, if there's another situation where funds can get locked to you other than somebody creating a channel in your direction. So Lightning Network is currently in a unidirectional state. So when you create a channel with somebody, all the funds start on your side. And the reason for that is that capital economic reason, that you wouldn't just, there's multiple reasons, but that's one of the major reasons. You wouldn't just want to allow other people to just take your capital and then commit it wherever. Somebody who, even if they put up some capital themselves, it's still risky because there's people out there with huge amounts of capital and maybe you don't know what their intentions are. So this is a way where you can say, instead of having somebody initiate a channel with me, I spend down my channel. And because channels are bidirectional, all the money that I spend down out of my channel, I'll be able to receive back. So a very simple way to do this even is, and one way that I thought that this would work originally, what I thought would happen is that exchanges would start accepting Lightning, and that if you wanted to receive some inbound liquidity, it would be simple. All you'd have to do is you could just go to the exchange, deposit a bunch of your funds on the exchange with Lightning, and then you're golden. You can just receive money. But at the state that we're at right now in the Lightning Network, there's not that exchange that you can just deposit your funds on. And even more, people who are offering accounts, Lightning accounts, and then they're also allowing you to withdraw your coins back to yourself, they're starting to notice that this is something that could be potentially abused. So there might be limits on how much you can do of that. So with a Submarine Swap, the way it can execute is you can choose any node in the network, and you can create a channel to them. The funds will start on your side, but as long as you can pay through them towards a swap provider, you can empty that channel out. And then, even better than putting it on an exchange, you can lock it into that contract, the HTLC contract, so that the funds return back to you on-chain. And because the funds are returning to you on-chain, it escapes the flow problems. So oh yeah?
Is there any way to batch the on-chain transactions in a swap?
I'll definitely get to that. OK, so that handles that super common use case, which is the I want to receive money use case. And people want that for all sorts of reasons. Another reason you might want to do this is you might want to actually just make a regular payment to a store or an exchange that doesn't support Lightning. So the kind of the reverse case of I want to buy something from a Lightning vendor. I want to buy something. I have my funds in Lightning. I want to buy something from a vendor who doesn't accept Lightning. And then the merchant also has a kind of a distinct use case where they don't want their hot wallet to limitlessly expand. So normally what's happening with a merchant is people are paying, and Lightning wallets are hot wallets. So they're getting more and more funds on their side of the channel. So throughout the day, maybe throughout the month, they're growing their size of their exposure of their hot wallet. So what they can do is they can use the swap provider to push out those funds. So they spend down their channels, and they can push out the funds to a cold address. They can push it back out to like a Trezor. And there's a lot of savings that they can still get from that, because what they're doing is aggregating their transactions. They're aggregating many, many transactions throughout the day, throughout the month, and it's going back to like maybe exchange, they're selling it, or maybe they're holding it for some reason.
So when you say it can get abused, what types of abuse?
Which can get abused?
You said you have to worry about this if you offer this service as an exchange, or
yeah, if you're an exchange, okay, so let's say let's say you're an exchange and you offer people the ability to deposit with Lightning off-chain, but then withdraw on-chain with on-chain funds. The issue is you yourself as an exchange have limited amounts of inbound liquidity. So the more people send to you, the lower your inbound liquidity goes. And then when they take it when they take it out on-chain, that inbound liquidity doesn't go up. It would be one thing if you paid them back off-chain. In that case, then the flow would be reversed, right? But because they're escaping the flow, they're going on-chain. That state of the network, it's permanent. So they're losing their inbound liquidity. Plus, I mean, if you're like not all the inbound liquidity is equal. So maybe your prime inbound liquidity is getting used up. And it's been a current problem that I've heard about. Especially as we.
If a service is offering both loop in and loop out, you think.
Oh, this is like an exchange. So this is like why you would want to use loop in and loop out, or why you'd want to do a submarine swap, because you can kind of address the network more broadly. Yeah. But of course, swaps still have the same kind of concept, which is maybe the flow is too one-directional. And that's why it's important when you initiate a swap that you connect to like the mass of the network, and you're not too isolated. And it's also important for the nodes involved to set their fees properly, so let's say that I process like 10 swaps, but now my channel's depleted. I need to make sure that the fees that either the traffic is bidirectional, so that I'm going to get swaps, I'm going to get routes in the other direction, so the flow resets, or I have enough money that I've made off of routing fees that I can close those channels and reopen new channels because the funds have moved from one side and then they went to the other side. So I'm going to have a liquidity problem that can't be solved within the flow network. I have to leave the flow network. Okay, so I was already kind of talking about that there is this problem in terms of routing economics. But it's a problem and a solution. So one of the nice things about a swap is that you can connect to any node, because this looks, from the perspective of those nodes, it looks like it's just a regular payment. They're just pushing out a regular payment. So instead of connecting to instead of buying a channel from somebody who's like a channel provider, you're going to anybody in the network, and you can kind of like pick and choose. You can say, I'm going to go for the guy who has the lowest fees or who's online the most. It seems like his business is being a great node. And also, I'm going to set up my channels in a diverse setup. So if that guy goes down, it doesn't matter. I have like 5 other people who are still up. So we also think this is like a healthy way that the network can spread out the liquidity so that it's not too brittle. Okay, but there are some problems with submarine swaps. One problem is that we are still using up chain space. That's kind of like we want the chain benefits, we got to pay the chain cost. Another problem is normally things in Lightning are pretty fast, but as soon as you get the chain involved, everything goes screeching to a halt. And it really makes you appreciate the off-chain experience, because off-chain experience, you test something in 2 seconds, it's done. When you go on-chain, you're waiting for confirmations, it's awful. And another thing that's not great about submarine swaps in the naive implementation is that from a privacy perspective, the chain is not ideal. You are broadcasting values to everybody in the world. You're broadcasting timing. You're broadcasting the pre-image so people know that secret. So that's not great. Just to get like technical about chain cost. So chain cost is one of like the most important things one of the biggest disadvantages of submarine swaps. And also, not only is it a disadvantage for the user, it's a disadvantage for everybody in the network, because the more chain space that you use, you're also driving up fees for everybody. So ideally, we can use the chain sparingly. So if we have a cooperative setup with somebody, we don't have to kind of go to this global court to fix things with each other. Okay, so let's like drill into what actual bytes, virtual bytes, are used in these swap transactions. So the swap transactions are actually two transactions. The first transaction is that you deposit money into the HTLC that goes on chain. And how that looks is it's got the normal, so if you're familiar with like how a raw transaction works, a raw transaction has some kind of like wrapper stuff on it. It's got this version bytes, it's got a lock time bytes, it's got kind of like these counters that tell a parser like how many bytes to expect coming up. It's got a marker and a flag byte for SegWit. It's got, okay, and then outside of that wrapper stuff, it's got the funds that I'm spending and then where I'm sending to them to. So the funds that I'm spending, that will be referenced with an out point. So I'll reference an old transaction ID and I'll reference an old transaction index of like which output I'm spending. And then I'm going to put in a sequence number, which isn't really used too much except for opcsv. And then I'm going to put, also we've moved around how the inputs are structured. So now the signatures that are part of like proving like why I'm allowed to spend these previous outputs, they're now at the end. And that's going to include like your public key, and it's going to include the signature of the public key, and then any scripts, if you have them, that are locking those outputs. And then once you've kind of once you've like pulled funds into the transaction, you also attach outputs where the fund's moving out to. Any funds that you don't attach to an output, they're going to be pushed over to minor fees. So the outputs, you're going to put an 8-byte value, and you're going to put a script pub. And so these are all approximate values. If you have different types of script pubs, different kinds of output scripts, it's going to cost different amounts. But an interesting thing to look at is that because of SegWit, we actually have a big discount on the public key and signature, which are actually a lot of real bytes, but much fewer V bytes. So that's a funding transaction. So now I've got this transaction confirmed on the chain, and this HTLC is now, there's a clock ticking on it, which that CLTV timer. So in the happy case, the swap counterparty is going to reveal the secret. So they in one case of a swap, they separately paid a payment request off chain, and now once they paid that payment request off chain, they got this secret, and they knew that secret corresponded to this HTLC that we set up in the initial transaction. So now they're going to use that secret to sweep the funds under their sole control, because what they're worried about is that timeout. If they don't sweep it, then the timeout clause can execute and the other person can take it. So the sweep transaction, it has the same kind of wrapper, like transaction wrapping, which isn't a huge amount of bytes, but it's still some bytes. And includes the same thing where it has to reference the last transaction. And it's even more signature bytes because we've got that pre-image in there, which is 32 bytes. So altogether, we're looking at, And I even simplified this because what really was going to happen is like when you fund this transaction, you're not going to have one output, you're going to have two outputs because unless the amount is exactly correct, you're going to have to move some funds over back to yourself. So we're looking at maybe like 260 to 290 V bytes that you're going to have to pay for. So maybe if fees are at 1 Satoshi per byte, you're going to pay 300 Satoshis, but if fees are at 100 Satoshis per byte, you're going to pay 100 times as much. That's no fun. Okay, so now that we've kind of established, though, about what the problems are, at Lightning Labs, we're working on this solution called the HyperLoop. And the idea is to take all these problems and kind of minimize them, but still retain the benefits. So the first problem that we're going to address is this privacy issue. So people can see on the chain that I'm doing these swaps. If you analyze the chain, you could actually see all the swaps that are being done. You could tell, like, how many swaps is Lightning Labs doing? I could have an estimate because I looked at all the blocks. So what we're going to do is we're going to bring back in the channel construction. So how the channel construction works is you create a multi-sig output. And the multi-sig output, just like in Lightning we have a funding transaction where we fund the channel, and then we create this child transaction, which is called the commitment transaction. And the commitment transaction, that's the transaction that kind of holds the current balance between the counterparties. But we actually never want to broadcast that commitment transaction. That's just kind of just like our safety net. When we close the channel, we'll cooperatively work to say, I have this signed commitment transaction that I could broadcast to the chain if I wanted to, but it's going to be cheaper for us and more private for us if we cooperatively sign something that just spends from the multi-sig to just any address, not fancy contract address stuff. So we're going to do the same thing with a submarine swap, but in a simplified, lighter weight version. We're going to say, when we fund this, we are going to create this funding transaction. But first, we're going to create, before we actually commit and pull the trigger on sending the funds there, we're going to set up this safety net for ourselves. We're going to say the funds could go into a regular submarine swap. But before they go into the regular submarine swap, they go into multi-party control. So what we'll be left with is multi-party control, which wouldn't be ideal if you didn't have the safety net. If you didn't have the safety net and you put your coins in multi-party control, the other party could kind of just say, oh, I'm leaving now, and then you wouldn't be able to get your money back. So we first create the signatures so that we could broadcast a child signature if we wanted to. We then fund this multi-party contract, and then we do the same thing that we do in Lightning. We say, we have this escape clause, and we know we could do it, but instead what we're going to do is we are going to do a regular on-chain spend, and we're going to hide from everybody the fact that we're even doing the submarine swap. We're also going to save money because we are no longer constrained by, we no longer have to include all of this proof data that we otherwise would need, and we can use something called signature aggregation. So that's something that we're also working on at Lightning Labs for ECDSA, which is that you can combine two signatures into one signature. We could actually, that's good for two reasons. For privacy, it's great because it looks like any regular signature. You couldn't tell the difference between it and any other signature. And you can do it today, no soft forks, you don't need anything. And it's also great because you are saving a bunch of signature data bytes. So now you don't need to pay for those. So we saved a lot on privacy, and we saved money.
When
Sure.
you do the elliptic curve aggregation, if you're unlocking a UTXO, do you need to publish on-chain all of the public keys?
No. You need one like consolidating public key. Yeah, and it can even be something like a public key hash. So it can look identical to any other normal payment.
Feel free to get some more walls back.
Oh yeah, sorry.
Is it a lot of work to get it working with ECDSA? Is it not worth waiting for Schnorr?
We do have something that works in terms of testing that you could go and check out on GitHub today, and like you could set up a two-party signature. The difficulty is making sure that it's like rock solid, and that we'd feel confident pushing it to production. But it works. You can have multiple parties sign, and the network will accept it. And then something that I'll get into is why we might not ever put it to production. Okay.
Is it faster as well, that version where you don't have to? Are you still pushing it onto the main chain?
You're still using the chain, so you're still waiting for confirmations. And in the worst case, it's actually worse. So you want, in the worst case, you're going through like more stages, right? So if you don't plan to cooperate, if maybe somebody's going to like mess with you, then it's better to use a simpler version. Okay, so HyperLoop for loop in is going to kind of take the same principle of creating like a lightweight channel. And we're going to bring in certain technologies to really save on space. So ECDSA, two-party ECDSA signatures is something that's going to take us a lot of work to move into production. But luckily enough, Blockstream has already been working on this concept, Musig, and they've been doing all of that work of like how to make them production ready, which is not trivial. And the really cool thing about Musig is that Musig is something that can work for any number of keys. There's no limits. You can have 100 keys in there, and it collapses to one signature. So that's a huge savings of bytes. You have a constant bytes. More people you load in, more money saved. So what we can do with the HyperLoop is try to get tons and tons of people to enter into one of these loops. And they all kind of get their same escape hatch. So if something goes wrong, the escape hatch can, that escape transaction can still be used. And we're also saving from these multiple transactions, right? So we have all these people are sending to this one output, right? They're sending all these, they're having all these inputs, they're sending to this one output. And this is a case where we don't have this great savings of the Musig though. So we don't always have the great savings, because if we're not in the loop in case, people are spending from different outputs, right? So they're not spending from the same one, so we can't condense it. But we still can get savings on the other side of this. We can get savings once they've already put it into the multiple Musig. Once we've already put it into this multisig, they can then spend it as one. And maybe in the future we'll get signature aggregation across multiple inputs, but that's not something that I would like hold my breath for. But we still get a lot of great savings, and we still get that privacy. The other huge savings here is that we can use atomic multipath payments. So normally in a submarine swap, you have one on-chain transaction, and it's corresponding to one off-chain transaction. So every time we do this, it's costing like 300 V-bytes on the chain. But we can use atomic multipath payments to say, what if I want to do tons of off-chain payments? I can collapse them all into one on-chain payment. So I can, if I want to refill a lot of channels. So in this case, loop in, I'm going into Lightning. So I've depleted maybe 10 channels. So instead of doing 10 swaps, I can do one swap, because it's all amped to that one on-chain transaction. And of course, also that has no limits. It's as many channels as you have, you get that much savings. And it gets even better with the loop out case. With the loop out case, we are no longer constrained by those inputs. So every time you add an input, you have you're referencing an old transaction, which is 36 bytes, V bytes. And then you're also referencing kind of that signature information, which cannot be aggregated. So we're we're having this heavy weight on our transactions, which is the signature information, and we're having the previous out point. But if you look at a transaction, those V bytes, if you're spending out, the V bytes are actually very low, because all you need is one script, and you need one value, script and value. So that could be maybe, if you're sending to like a single key, it can be maybe 30 bytes altogether. But anyway, much less than all those inputs cost. So what we can do is that the swap provider can control a massive input, very big input. And all the people who want to loop out, they want to get their funds out. They send to the swap provider off-chain, and then the swap provider takes this massive input, and he says, OK, here's a 30-byte output for you. And as more and more people enter into this HyperLoop, I can say, here's a 30 for you, and here's a 30 for you, and here's a 30 for you. And we're also cutting back the change, right? So you just get the output that you want. And we have a fixed cost otherwise. And just to go like into a little bit of detail about how AMP works, AMP isn't actually all that complicated in the simple case. So in the simple case, what's happening is, and let's just go to the Lightning Network for this. In the simple case, what's happening is, in a normal HTLC, somebody comes along and they say, I'm going to lock 1 Bitcoin to you, and then I want you to lock 1 Bitcoin to somebody else. And the reason that you would do that is because there's a difference between those, where there's a fee that you're going to get as long as this entire chain of HTLCs completes. And you look at, OK, here's one Bitcoin coming in on this side. So it makes sense for me to lock 1 Bitcoin going out, hopefully. But what happens if somebody locks half a Bitcoin to me, and he says, please lock 1 Bitcoin going out? Normally what I'd say is, no, I'm going to be losing money. But he could tell me, you know what, I'm going to send half a Bitcoin to you, but then hold on a minute. Don't error back to me. I'm going to send you half a Bitcoin somewhere else, and it's going to be locked to the same pre-image. I'm not changing up the pre-image at all, but I'm going to lock both of these to you. Whenever you have a lock that's set up, normally you would never use the pre-image. But because I wait for the lock to be set up, so I wait for the commitment transactions to be signed, I say, OK, I've got one half a Bitcoin locked to me, and now from another point, I got another half a Bitcoin locked to me, and they're keyed to the same payment hash. They're keyed to that same secret. So now it makes sense for me to send out 1 Bitcoin going out, because once that goes out and I get the pre-image, I'll be able to take these 2 coming in, and I'll be square. So that's how HyperLoop can work, also without very complicated changes, no soft forks or anything, just based on that simple logic that we're going to say all the clients, like let's say I'm a busy merchant. I've got 10 channels. I've got 100 channels that all have got tons and tons of money in them. Well, that's the end of the day, and I want to push them all out. So I'm going to go to the swap provider, and I'm going to say, look, wait for this amount of money. And I'm going to be locking all of these to the same pre-image. And then when the swap provider has enough funds that are locked to it, it will say, OK, I'm going to aggregate those all into this one on-chain output that's going to correspond to that same pre-image. So we're going to get huge chain savings from all of these individualized off-chain transactions that are being moved into one instead of doing a new swap for each one. And I would definitely say that in terms of forks, so we saw before Museg that depends on the Schnorr soft fork, but also will be helped by Taproot, and that's potentially in that same fork for all these escape hashes. Because one problem with the loop out is what happens, and in all of these cases, what happens if somebody doesn't cooperate? If somebody doesn't cooperate and we're not cooperatively signing, then we all have to go to these escape hatches. And this even is a problem for us actively with the Lightning Loop service. So with the Lightning Loop service, when you loop out, what's going to happen is that we're going to pay on-chain. And then when you see that payment on-chain, you're going to pay us off-chain. because it doesn't, you're not going to want to pay us off chain if you don't see that you're going to get reimbursed. So that's the way that we make it non-custodial. But we are paying on chain. So we are paying chain fees. And you can cancel. You could say, oh, I'm not, you know what, I changed my mind, I don't want to do this. And we just still pay those chain fees, and now we have to pay a timeout fee because we have to wait until it times out. So we've got our capital locked up, and then we need to like pull it back. So we're going to pay 2 chain fees.
Surely you only pay the chain fee if the swap goes through on both sides.
Well, that's not the simple way to do it. So the simple way is you set up this HTLC, and then you paid the chain to do that, right? So we're talking about on-chain, not off-chain. Off-chain, if there's a problem, we can fail it back, and nobody has to know about it. But this is all on-chain, this part. So we've published this on-chain transaction paying to an HTLC, and then we say, please pay an off-chain payment request that we've made in order to get the pre-image or you're going to publish a pre-image when you do the sweep. But basically, like, we are going to match an on-chain to an off-chain. But if it doesn't work out, we're going to go back to ourselves. And in order to go back to ourselves on-chain, we're going to have to pay a chain fee. So in order to solve that, we currently have what's called a prepay. So whenever you initiate one of these swaps, you pay us in advance for that chain fee cost and kind of like to anti-DOS, because we wouldn't want somebody to just spam us with tons and tons of requests and make tons and tons of chain requests that never were fulfilled. So that's also something that we can do with the HyperLoop to kind of try to make sure that everybody's cooperating, is that if you don't cooperate, there's a small component which is like anti-DOS. There's other ways that the swap could be constructed to make it so that you could maybe attach your own inputs, and then you could attach another output, which is a chain output. But this is kind of the simple case, and also uses minimal chain space. Yeah.
Then does the HTLC pay the fee back, or does the person actually pay the chain fee at the end of it?
So we kind of refund it. So we say, put a deposit down for that timeout case. If the timeout case, if there's a problem, we're going to take that money. But otherwise, you're going to get it back. Okay, so we're already kind of setting up for this coordination of this massive multiple signer. Okay, so I kind of want to like circle back to what are the actual chain costs of the HyperLoop. So this is kind of the same rundown of like how the transactions are going to be represented on chain. The thing to think, and this is like the HyperLoop out. So this is showing the HyperLoop out. And in the HyperLoop out case, the thing I want to like really highlight, so we've actually saved some money on the pre-images because we removed the pre-images, so those are no longer represented. But also they already had the SegWit discount, so they weren't hugely contributing. But the huge thing that was contributing is that we had all of these every time we did a swap, and even if it was every single swap we were doing more and more chain transactions. But with this, we only have to attach more outputs, and an output is so cheap. So all that we're representing instead of 300 bytes is we're representing 30 bytes, 30 vbytes. And that's not even thinking about AMP aggregation. If you AMP aggregate, AMP aggregate maybe 10 channels into every swap, you're only using maybe 3 vbytes. And all the other costs are static. So all we have to do is kind of like coordinate a massive swap between a bunch of people, and our chain impact is actually pretty minimal. And we still get those great benefits of escaping that flow network constraints. Okay, so I just want to like kind of sum up a little bit about kind of our philosophy of developing HyperLoop. One thing that we're really focused on is trying to match it to what people's immediate needs are. So the biggest need we saw was a loop out, because people want to play with Lightning, they want to receive. And capital is something that is like a hard problem. Like who should get it assigned? So we've provided that with loop out at the moment, and we're trying to make it cheaper. But another thing I've been thinking about is that if we really want to make Lightning take off, one of we can kind of see the answer right in front of our faces. That people are paying $20,000 every block. Every 10 minutes, they're paying 20 grand to do something that can theoretically be done with this network that we've created, at very minimal cost. And the practical reality is, at the moment, the number of exchanges that accept Lightning, the number of even stores, just regular stores that accept Lightning, is pretty low. But loop out with HyperLoop could actually just save your regular on-chain costs. Because what you could do is you could say, I have these on-chain costs that I regularly pay out. So whenever I'm making these normal on-chain transactions, I'm going into my wallet, I'm selecting some inputs, and then I'm making an output to where I want it to go, and then I'm making another output that's a change back to me. So what I'm doing is I'm spending a bunch of money on selecting these inputs, and I'm spending a bunch of money on selecting that chain output, and then only out of those 300, or out of like 150 V-bytes of my transaction, only maybe 30 of those V-bytes are what I actually want to do, which is send an output to the exchange, or go to the store that I care about. So even if you don't care at all about Lightning, if you just establish some channels and you use a swap provider, the swap provider can kind of give you a ride on one of these loop outs. And it can say, OK, forget about that change. Forget about those inputs. All that you're going to get is that output that you wanted. And you're going to send us off chain, and we're going to basically do what exchanges do. We're going to batch everything up together. And in anticipation of this future, we've pre-adjusted the costs for Lightning Loop. So Lightning Loop, our charge for it now is actually lower than cost because we anticipate these savings coming in the near term. So if you try it out and you start to integrate it into your existing systems, it will cost you closer to what those future costs would cost, because we know that in theory this works. We just have to do the work of actually building it out. That's it.
Okay, we'll do Q&A. Focus on HyperLoop, loop out first, and then once we've answered those questions, we'll go on to anything Lightning or Lightning Live, which is LND related. So questions on HyperLoop.
OK, ciao.
Do you have an ETA on launch?
So we're gonna do it very iteratively, because HyperLoop involves lots of different components like AMP and maybe two-party ECDSA. And there's another component that I didn't even talk about, which is what are the fees that I use? The fee can make 100x difference. If I have a low time preference, I can set up these swaps to take days. But if I have a very high time preference, I want it to happen right away, I'm going to pay more. So we actually have in a pull request right now in the repo something that allows you to choose your sweep cost, so you can save 100x on the sweeps. And then we're going to add that out to the rest of the components so that you can specify your time preference. And time preference is also important to set us up for these aggregated things, because we need to collect lots and lots of people onto these transactions. And it's not every moment that there's going to be maybe 100 people wanting to all grab onto one of these loops. But over the course of the day, we can say, oh, there's lots and lots of people who are going to enter into that loop, and we can merge them all together.
How are you sort of planning to expose this? Is this just going to be APIs, or are you looking for more focused as well?
Currently we have an API, so you can go to our GitHub, and there's a client, and the client is like open source, MIT. It talks to an API. So it's a way to kind of demonstrate doing a non-custodial use of the API, but also just something you can practically use. And then we've planned to integrate it into our desktop and mobile app. So people on iPhone, Android, we haven't worked out the user experience, but we'll try to like integrate that so that people are getting the savings just without even thinking about it, or they're getting the advantages I want to receive. So I just can press a button that says it works. And other wallets have already kind of beaten us to the punch even. Moon Wallet, Breeze Wallet, they've got Submarine Swaps integrated already.
And you plan to be the only market maker of that initially, or?
Well, Submarine Swaps, it's not super complicated. So somebody can set up one of these services. But the thing that we're focused on is really creating a production-ready service that a lot of people can use. We want people to build on this. And the advantage of people like building on it for us is that we can do more aggregation. So we want to get tons of people to aggregate. And the more people we can aggregate, the faster we can do these loops. So that's one reason we want people to build it into their own apps, build our APIs into their own apps. Yeah, and then we will also include it in our own app. So it'll be usable both ways. Right now, there's like a command line version you can try out.
I'm wondering, do you have any idea on how cheaper or more expensive would be to use these instead of paying bit refill to get inverse capacity, for example?
Well, I don't think that they're mutually exclusive because these things can actually be like hooked right into channels, right? So the output is just any output. Like a loop out output, you could have that output be the funding transaction, be the funding output for a new channel. I would say the bigger question there is a question about liquidity. So liquidity is a market itself. I want to get $100 million locked to me. So how am I going to do that? I'm going to have to probably go to liquidity providers. So I think that there's two separate markets there. We're more focused on kind of the ongoing process. So the submarine swaps are more focused on like ongoing usage. And the network can kind of adjust to these swaps going on. They can say, okay, I'm going to I see that there is some movement in this direction. I'm going to assign more liquidity. With the bit refill style, which is something that I also played with on yalls.org, you could buy a channel. It's more about just like I'm throwing a party and like I want everybody to pay me for beers, and like also the amount is larger than like a swap would really work with. And we also with swaps are kind of constrained by, until we have AMP, we're constrained by the values. So we can't do a swap for like 0.16 Bitcoin.
Questions on
Can you do like a couple of swaps with yourself within the same block? Like I read about the loop-to-loop.
Sure, yeah, the loop-to-loop is a cool, very cool concept.
You loop around.
Yeah.
Could you potentially pay a couple of invoices to yourself, and you'd be adding a couple of signatures of your own together, perhaps in that way?
Okay, so the loop-to-loop concept is, it's kind of like, I want my channels, like let's say I'm a new user, or maybe my app wants new users to have perfectly balanced channels from the get-go. So because maybe they don't understand this channel liquidity concept. So when they put in $20, I want them to be able to receive $20 and send $20. That's easier than when if they just put in $20, that they have to wait until they've spent down that $20 until they can receive $20. So what I can do is I can say, I'm going to do one loop to get all of that money out, and then I'm going to send the money back to myself, and then make a new channel out of that. So that I can maybe even use the output of the loop that's the success output and make that into a channel. So now I did this one loop and I'm balanced. But you could even potentially go further. You could say that channel will now do a loop out, so I'll get even more liquidity to me. I'm getting even more liquidity to me because I'm looping and looping and looping. And so I could have a very unbalanced. So let's say I'm setting up a merchant maybe. In that case, I could do tons of loops with a very small amount of capital. I don't need to have a matching amount of capital, which is a kind of a constraint of a swap. I can get like $100 of liquidity bound to me even with only $20. The cost there is that you're paying these fees every time you're doing it. So we'll kind of see how that works out. And then for splicing, I'd actually say that this is kind of like an alternative to splicing that could potentially be savings, right? Because a splice in a normal scenario is, it still carries that baggage of those inputs. So you're changing of course you're changing your channel around, but you are paying money to represent inputs on chain. And maybe you're representing change on chain to go somewhere else. So I think that it can kind of be cost competitive with splicing. And it has other benefits which are like, if you're a routing node, I think one of the signals that people can use to do pathfinding is they can look at old channels. They can say, this channel has been around for a long time. So I know it's probably stable because these are 2 nodes that I've had experience with. So if you do splicing, you are like erasing kind of the history of your channel because it's no longer placed in a very old block. I mean, potentially we could kind of like have the history like connect to it, but that's complicated. And the other thing is splicing, we don't have it yet, and this is something we can do right away.
Could you tell us a bit about how Lightning Labs has been managing the kind of BTC reserve versus what's in their channels? Because as people loop out, then you're having to spend some capital reserve that you have in BTC.
Yeah.
At some point you need to balance that out.
Yeah, Lightning Labs we have our own problem because we run our node. We have our own liquidity problems because what we're doing is kind of selling you liquidity, and that's not really what we want. So we're not focused on that business, which is kind of like what Thor has been working on, Bitrefill has been doing, is like just really purely monetizing that capital. And our philosophy has been more low key. So what we really want, we want the network to be healthier. So we don't even really publish our node. We don't want you to be swapping directly with us. What we want to do is we want to create a global network where if you connect to one, you can pay all. And if we allowed a lot of people to connect to us, it would create a network that was localized around us. So we're kind of trying to discourage people from connecting directly to us. Instead, we want them, and also it's better from a privacy perspective. So now the funds aren't flowing through us when you're spending. They're flowing through whoever you picked. So maybe you picked your friend. So now the funds are flowing through your friend when you do a spend. We do have an issue with funds moving maybe too much in one direction. And that's one reason we recently launched Loop In. So before we only did Loop Out to deplete your channels. So now we have Loop In, which goes in the other way. You can refill your channels. And that's also another reason why we want that global network. We want to make sure that those flows can be more balanced. And in actual practice, like, we want the flows to be equal. But that's why we even have these submarine swaps. It's because in real life, capital flows are not equal. You go spend at a store, and that store isn't going to take that money and directly send it back off-chain to make the bidirectional channels perfectly efficient. And so we have the same problem. So what we do is we close channels and move funds on the chain when we need to move capital around, just like because we're using the chain just like a submarine swap would use a chain to escape flow problems. And then the other thing we're trying to do is we're trying to like educate people on how to run a routing node. So how to set your fees properly, and then also how to make money by taking advantage of people doing traffic on the network. So hopefully what happens is we have a lot of people looping out. And so what they're doing is they're sending traffic in our direction. We want people to notice and say, wow, this is a great sync. Like, and maybe not to us, but maybe to one node or another node, and they're saying, oh, this neighbor is getting lots of traffic. So what I'm going to do is I'm going to take the funds that I've made doing that routing, and I'm going to commit even more capital in that direction because that's a highly used direction.
So when you say submarine swaps and loop in, loop out, they're exactly the same thing, right? It's just a terminology.
Loop is more like their brand. Like, this is a service, a production service that you pay for. And submarine swap is more like, here's the technology. Like, here's the concept.
General concept.
Yeah.
Loop in, loop out is a service provided by Lightning.
Lightning Loop is a service, yeah. And it's also a proprietary service. The server is not open source.
Okay.
So I have previously written an open source submarine swap service. It's, there's the devil's in the details, and we're really like locking down on providing production uptime, providing good rates, providing good liquidity to the network, making it, building out that tool set.
Okay. And you release loop out before loop in just for a demand, just due to demand. There's no extra complexity.
It was much more difficult to do loop out because of this problem with doing the on-chain payment. So that's one reason why I didn't implement it. It's because it requires to do this kind of locking, and we had to change L&D to make it able to support this type of a swap. It uses hold HTLC, so it holds onto the HTLC, which is a feature we had to build. But yes, the demand was there for moving funds out, and we're also like trying to think as we build production services, how can we be representative of the people who are using LND to make things? Because that's the best way for us to know what to add to LND, is to actually run into the challenges that other people are going to run into. So when we make the mobile app, we can see here are the problems that mobile app developers are going to have, because we have our own mobile app. And when we make like services that are production services of LND, we can be the first ones to encounter all those problems that somebody who's trying to run an exchange, somebody who's trying to make an app, because we had to face those problems ourselves.
And another couple of questions, I don't know if I answer anything. So with HyperLoop, you'd need that whether it's an API or whether it's just a service you're providing, there's a coordination problem, right?
Yes, the loop requires, in order to create this like massive multi-signing system, you're going to need to have a coordinator, or some decentralized version of a coordinator if you wanted to make a competing system. It's just easier for us to set ourselves up as a coordinator, and it's non-custodial, so we're coordinating, but we can't mess with the funds. Yeah, which is it makes it easier actually for us, because we don't have to like be so paranoid about security, because in the worst case, people get their money back.
It's like half a coin join, isn't it?
It has a lot of the privacy benefits of joining your coins in terms of like the UTXO, leaving the UTXO footprint behind. Even doing a regular submarine swap, the settlement is happening somewhere out there. And so somebody who's just looking at the chain is like, oh, I saw some funds move over here, and now there's funds over here. I don't know how that happened. I wouldn't say that we are super focused on providing the maximal privacy in the current iteration, because like you could still like I mentioned, you still see the pre-image on the chain. That's something you wouldn't really want if you were just making a purely privacy-focused system. But privacy is pretty important to us, and we are going to include more elements that make it like more invisible. And the way that you access our service is also private. We don't know who you are. We don't have your email address, your name, or anything. And it's onion protected, right? So when you do this loop with us, and that's also why we want you to connect at a distance. When you do this loop with us, you're paying us off-chain. We don't know how where it originated. That's part of the Lightning Network.
Final question on looping about. So I'm interested in why some parts are part of, some services are included or integrated within LND, and some are like external to LND. So
Yeah.
So Loop has its own daemon separate to LND. Why is it not integrated with LND?
Yeah. We separated the daemon from LND, the loop daemon from LND daemon, because number one, the loop daemon, it sounds like it's a big heavyweight thing. It's really not, right? It's just doing that one transaction type. The only reason that it's like called a daemon is that you need to worry about those timing risks. So you need to keep it on so that it can like kind of bump the fee maybe if there's a problem. But it's not like a very complicated piece of software. You could implement it yourself probably if you just spend some time on it. And then it's not part of. It uses our service, right? We're building it to use our service. And L&D is something for the community. We want that to be a community-driven platform. We want people to submit features to it. We want people to build on it. So we want to have kind of like a Chinese wall between those two different things.
Okay, cool. So open up questions on anything L&D. Lightning Labs is a new L&D release. So any questions? Oh yeah,
L&D 0.7.0 is out now. I would definitely recommend everybody update it like right away. Yeah. Awesome.
Is there much of a, maybe this is a silly question, is there much of a healthy network on testnet? Like a testnet Lightning network? Do people use that?
It's healthier than the Litecoin network. Yeah. It's not so bad, but and also the mainnet network. The main network has, like, I would say, so one thing I do is I measure healthy nodes in the network. In addition to working on Loop, I also work on kind of the other side of it, which is kind of like monitoring the network. And I would say that the main network maybe has 250 nodes that are great routing nodes, out of thousands and thousands of total nodes, just anybody installed it and made public channels. And I would say that the testnet has maybe 50 good routing nodes, pretty okay. A lot of services like run a testnet node in addition to their mainnet node. And then Litecoin, I would say, has 25 maybe strong nodes. And of course, there's a lot less money, which is kind of funny. Even though testnet money is free, there's way more real money than there is testnet money.
Any other questions?
Do you know any good routing nodes behind Tor? Functional?
Are there any good routing nodes behind Tor?
Can you see that?
Well, I mean, my node is a great routing node. I'm behind Tor. There's also two types of nodes behind Tor. There's like the Tor, like they also provide a Tor address, and then they provide normal address. One problem with Tor nodes is that you need Tor to connect to them. So they struggle with inbound liquidity because regular people don't have Tor installed, and so they can't connect to them. So Tor can connect out. Tor can connect to the ClearNet, but ClearNet can't connect to Tor. Another problem with the Tor node is that it's wrapping one onion inside of another onion. So you have a slowdown. Like Lightning is already kind of slow because you have these, like you're going from one hop and then unwrapping and then going to the next hop. But you're doing that now another time because you have just even the regular networking does that with Tor. I think Tor node support is growing because we've been trying to like prioritize it in L&D in terms of fixing like supporting it as a first-class networking stack, and like Casa HODL, they've been trying to get people to install it, not just for privacy, but also to provide to avoid people from revealing their IP address to everybody, and to provide a consistent address for them to connect to, because you create a hidden address, and even though your IP changes, your hidden address can stay the same.
That's true for Nodal and the Raspberry as well. So.
Yeah, so I've definitely seen like an improvement, but I would say like only 10% probably are like of good nodes are Tor. Yeah, and they struggle with this liquidity problem.
But they can do both.
Yeah. So, or you could make a clear node and a Tor node, and then you can move it liquidity. So if you have inbound liquidity on the clear node, you can move it over to the Tor node by sending between the two nodes. So I have both nodes. I have a clear node and a Tor node, and I can move liquidity if I need it. And I actually do similar amounts of routing on both nodes.
How are you sort of approaching this from a sort of regulatory perspective? You're going to moving in all that
Oh yeah.
money and the privacy is obviously
Yeah.
How are you sort of approaching that? You can end up with a shapeshift kind of problem in terms of
From a regulatory perspective, I think the biggest thing we focus on is having no custody. And we also have really no rates, right? Like we're trading Bitcoin for Bitcoin. So we're basically providing a service to you of just moving your Bitcoin around. At least we're aligned kind of with the regular network. So with the regular the regular Lightning network, they're moving Bitcoin from point A to point B, and it's non-custodial. So I'd say from a regulatory perspective, like that's what we think will work. I'm not a lawyer, I don't know. And also it'll probably vary from country to country. But that's like our thinking.
Would the prepayment fall in that category?
The prepayment, it's something that we've kept small, like for that reason, to try to make it so that the bulk of your funds are not represented by the prepayment. If it were a problem, we could set it up so that users had to kind of bring their own inputs. We could also do something where you had some other way to kind of prove that you can't costlessly attack us, because we're having to spend this money, and you could be anybody. But I'd say it's more akin to like a service fee.
So I'm just into Tor nodes because I'm running like two of them and no clear node. And then there's been a discussion amongst people that the payment speed, the actual Lightning payment done with Tor nodes is significantly slower. Do you experience that?
Yeah, I mean, people have said that Tor nodes are slower. Since I switched over, so y'all's now is actually 100% Tor. Since I switched over, I do notice that it is slower. Part of it is actually because we just weren't working on Tor, right? We were working on all sorts of other problems that L&D was having. So we weren't running Tor ourselves, and we weren't also working on like the high latency mode, which is something we are working on now. So we're running Tor more ourselves, and also because we're working on the Lightning app, which is designed to be used like with your mobile connection, the same principles that's going to improve the operations of a phone are going to improve the operations of a low latency or high latency node that's on Tor.
Do you think that implementing into the nodes to be Tor relay nodes as well would help this, or
to implementing what?
To be a Tor relay node as well, but most of the communication which is delayed is happening on the Lightning Network, right? So that is not.
Well, there's like all sorts of sources of delays.
Yeah. Right.
Tor is just one delay, and also there's a lot of like tuning that's happened in L&D. Like how long do I give the other person? How long do I retry? How many retries do I do? How do I extend the retry time? And one of the biggest time delay things is that we currently have a pathfinding system that is very unsophisticated. We just do a simple Dijkstra over the graph. So, and we start, if you actually like watched, so what you normally see when you pay in L&D is you say initiate payment, and then it blocks, or it looks like it blocks. It's like spinning, 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 and it's like payment failed, or payment succeeded. But if you actually watch what was happening, what would be happening is it would first do the Dijkstra to say, okay, what's the cheapest route? And then it would try fee 1. And then it would say that didn't work because there would be some route failure. It would go route 2, route 3, route 4, route 5. It could try 100 routes. And the worst thing is, up until point 7, after 30 seconds, it would forget about it, all of the previous attempts. So the next time you went to pay, it would just try all of those fees, 1, 2, 3, 4, all the way going up. So what we're working on for speed is make it get the right route the first time. So we're going to like attach a cost to failed routes. So if I don't want to save 1 Satoshi, and I know this route is probably going to fail, I'm going to skip over it. And then there'll be a time component. That's a kind of complicated thing for us to implement, but that's one way that we can get like much, much faster payments.
So at what point is that Tor slowing down this process? Because
so Tor just adds latency to everything. Every time we connect to our peer, we're just having to, like every time we do this payment attempt, we have to kind of set up a new commitment transaction with our peer. We have to do some back and forth messages and signing and stuff. And that's taking more time because we're on Tor. If we just had that one time that we tried it, it wouldn't be so bad. Yeah. And we also are thinking about how to like change the protocol. So the protocol itself is getting upgrades. One upgrade that we're thinking about in order to make payments more reliable is to include better errors. So right now, when we get an error back, it's actually not trivial to figure out like who I should try next. I got an error somewhere in the route. It's onion wrapped. I don't really know where it failed. So right now, whoever failed it will sign like a reason that it failed and get back to you. So you kind of have to interpret that reason and say, okay, that reason means that I should try this way or this way. But I don't get too much information. One thing we want to do is add maybe like what I saw to every hop. So one attack that you could carry out on the network today is that you could just slow things down. And that's something that I think we really need to be careful of when it comes to Tor, which is we're trying to think ahead about this attack, which is like I just behave like a very high latency node, and I still maybe carry it out or maybe fail it back, but I just take a long time. And well, it's like HODL route. Yeah. So we don't really expose this API, so you'd have to kind of like hack up your L&D. Maybe C Lightning has this hook, but you could just kind of like take your time. And what I want to be careful of when we do this optimization is that we don't over penalize Tor, because those Tor nodes are going to take extra time. And it's a judgment call. Like, do I want to spend that extra time waiting for my payment to go through? And I think it's, I wish that the whole network were Tor, because it's going to improve privacy for everybody. And one person's privacy also extends to other people. But we'll also have to kind of balance like growing the network and providing great user experience.
Assuming the Lightning Network is a massive success, can Tor scale that success, assuming, let's say, was to use Lightning Network? Can it scale Lightning Network?
I would say we need to like adjust how Lightning works. Like we need to continue to evolve the protocol. So the fundamentals of the protocol, where I'm just like exchanging states, like all I'm doing is basically exchanging a signature with my peer, exchanging a little bit of metadata. That can scale on Tor pretty good because the overall network is just created in a way where I'm not sending out too much traffic. And that's also one of the reasons why the errors are not sending back a lot of information. Everything was designed very explicitly to keep the data as pretty compact. The things that I think would probably fail if we had a huge usage of Lightning Network and it was used in a way that we didn't expect is the gossip system. And that's something that we've already had to deal with just because the network grew so quickly, and the current system of gossiping who the nodes are, what the channels are, what the fees you should pay, what the time delays you should do, which channel is online, which channel is offline. That data started to get out of control, and we had to like lock it down. So I think in LND 0.6, we created a new system for that that solved a lot of those problems, and we really optimized it. But we still anticipate going forward, we're going to have to like improve that gossip system, depending on how like the network plays out. It might be that there's actually a small number of public nodes, and the bulk of all the nodes are private non-routing nodes. It might be that tons of people want to be routers, and then the gossip of traffic between people announcing things is just going to be huge. It could be people are trying to change their rates up all the time. So we'll have to be adaptive. Yeah.
Quick question: so I'm set up this way. I have two nodes. One is watching another because only one has funds on it. So the question is, if the watchtower is offline, then in that time, if a transaction happens on the active node, then the watchtower it won't know about that kind of justice transaction, so it won't be protected. If that state would be broadcasted in the network, it won't be protected by the watchtower.
Like if the watchtower misses an update?
Yes. Yeah. Or if I connect my node to a watchtower, it won't know about the previous states at all, obviously. So it needs to be online when those changes happen.
Yeah, it needs to be online to hear about the potential breaches, and then it needs to be online like when a breach happens. Although there's a time lock, so like potentially you can have 2 weeks or something, and then you don't have to like. We probably wouldn't even want to update it exactly when things happen. You would say like maybe after 15 minutes you would tell it, and maybe you'd have like a buffer of I want to tell different nodes. And then you might also be consistently telling it at different justice transactions because you might want to have different fees. So like, let's say that they broadcast a justice transaction, but it's at fee 1 Satoshi. And then the timer runs out and the time for justice is over. So you need to kind of like make your fees commensurate with like your risk.
So with previous releases of LND, you're monitoring the chain on behalf of yourself on the same node, right?
And existing and previous. You're always watching the chain to see if there's some kind of problem.
So when you said the new release with watchtowers integrated, that's for the case of me running 2 nodes,
yeah,
and one of those nodes being a watchtower node for my node.
Right. Watchtowers is for your. I mean, we intend for them to be set up in a way.
It's for that use case. Yeah.
Exactly. We intend for them to be set up in a way that one watchtower can watch for many people, and it's not so complicated to make that use case happen. And transactions are relatively small, and they can be updated and kept around, and we can also change how HTLCs are represented in terms of signatures. But this is kind of like the first step. We got it in a release. You can turn it on. You can set up a watchtower for your own node, and you can run a watchtower for somebody else. And then we're also working on the protocol of like, this is something we also want to put into the standard protocol. So that's another reason why it would be a part of LND itself.
Can the watchtower listen over Tor?
I think it should work with Tor right away. Like I think the current version should work with Tor. I haven't run it myself actually.
Yeah. Okay.
Yeah, but we've been running watchtowers internally for a long time, and I think it should work with Tor, but I don't know exactly.
Yeah, because I could only use the IP, the clear IP of my node, and like
I think you might have to You might have to like set up some kind of like tunnel so that you like connect to you set up the Tor connection separately. But I don't know. Yeah, hopefully, like if there is a problem with Tor, we definitely need more like hands-on Tor like pain points to be represented in the issues. So like if you run into this, I would make an issue. Yeah, and it's a priority for us. Yeah.
It's the Watchtower standard. It's going to be part of the bolts or the specification.
Hopefully, it can be part of the bolts. So I mean, Watchtowers were part of the original white paper, and they were influencing the design of how the transactions were even formed. So we think that they're useful to all implementations, and like we would like it so that one Watchtower for one implementation could serve as a Watchtower for another implementation. But we've got a ways to go.
I don't know the precise details, but the L2 paper talks about some enhancements.
Yeah.
With Watchtowers.
Yeah.
Does that simplify? My understanding is that simplifies a lot of this need to hold
these
transactions.
I mean, if we did have L2, L2 is kind of far out. So like we have Schnorr Taproot, that's kind of like, even that is kind of far. We have to like get consensus around it. Then there's another soft fork, which is kind of like the cleanup soft fork that we're talking about. And then there's state cache no input that would kind of like provide different channel constructions. So the advantage of L2 is like you can no longer really have these penalty transactions. You just have like your out of date transactions. You still have to have somebody kind of watching because you can still steal money, but the money doesn't the punishment is no longer you lose all your money if you try to steal. And the reason for that is that we don't want to we potentially don't want to punish people too much for using an out of date backup. Although we have another system in the current protocol called data loss protection, which will warn your peer if you are trying to use an out of date state. And in practice, so far, it's been pretty good to stop this from happening, as long as you connect to peers that are like online. If you connect good routing nodes, if you connect to nodes that are bad, there can be this case where L2 would be helpful, where one node force closes, but it force closes on an old state, and then the other node wasn't around, so it wasn't able to connect to them. So it has to do this punishment system. L2 allows for more simple watchtowers because you don't have to keep as much old signature data and stuff around. I'm not super deep onto why it's beneficial, and I also think that we will potentially still have a mix of L2 channels and regular channels depending on the values because of the economics of it. So if I stand to gain $1,000 and L2 has eliminated the penalty for me trying to take that $1,000, why don't I just try? If the watchtower catches me, the watchtower catches me. I didn't, but if it doesn't catch me, I get $1,000. The only thing that you really lose, which is potentially a bunch, is you lose the chain fees. So I tried to steal, so that cost me an on-chain transaction to try to steal. So I think the way that it will play out will be more along the lines of value. So if the values are small in the channels, then that chain fee will actually be a serious component. So, and also the risk calculus will be different. I don't stand to gain too much. If the channel is huge, then am I going to put $1 million at stake that they could just try to take it and there's going to be no penalty for them? In that case, maybe I would want to work into penalty. And L2 potentially can even be adapted in certain ways to make the penalty more moderated. I really think this is far out stuff though, because of the soft fork thing and because there's so many thoughts about how we could do it.
So another thing in point 7 was the ability to pass your own randomness for seed creation.
Yeah, late addition.
What's that?
That was a late addition.
Okay, so I'm trying to get my head around it in terms of AZ and so BIP39 should be replaced, even though hardware wallets are currently using BIP39, and then I'm struggling to think what I need to back up. It's a big both my on-chain funds and my Lightning.
Yeah, there's a big questions around Lightning LND has its own seed format that we came up with, and It's not exactly BIP39. BIP39 is like what's used by most wallets, like that are based on like Trezor's mnemonics system. And there's a lot of questions about how we should like message to people like what you need to back up. Because if we do, so normally people are used to the mnemonics. And they like the mnemonics because it's simpler than saving a file. You just write something down on paper. Maybe it's even more durable. But in Lightning, not everything is represented by that mnemonic. And it can be confusing to people. Like, why did my channel funds not return with the mnemonic? I'd say that like this is such a deep subject because people have a lot of different opinions on like what should be done. The opinions in our seed, we have two opinions that we've changed from BIP39. One opinion that we've changed is that, and even BIP39 is opinionated. Bitcoin Core doesn't use BIP39, so it's arguably not a standard because there's lots of wallets that don't use it. Electrum, said, oh, this seed format isn't working for us. So the thing that we added is the aversion to the seed to say, okay, what does a seed even mean? A lot of times, if you actually try to like load up a seed, you have to kind of match like which wallet did I actually use and is it on the same standard? And there's a lot of nuance to this. Even if wallets are on the same BIP39 standard, maybe they have different like values for like how many addresses am I skipping over? I'm skipping over this amount of addresses, or I'm skipping over this amount of addresses, and they can like make it so it looks like your funds are gone. And then we also added a birthday. And the reason we added a birthday is like, when did your wallet start? So that instead of like looking over the past 10 years of the blockchain for all of the transactions that could potentially be in your wallet, we just know like, oh, let's only look at the last 6 months of the blockchain or whenever you started your wallet up. And so we've made those two changes in a seed. So the other component, like the story of like what to back up at the moment, I would say is use a watchtower for yourself. Copy down the mnemonic. The mnemonic is like the master key. And then you're not going to be covering your channel states. So all your channel balances and stuff are not covered by the mnemonic. So what you need, and also not covered by the watchtower. So what you're going to want to cover is, what you want to do is you take the static channel backup. So that's a feature that we added to represent your channels in a static way. They only need to back up one time every time you make a channel. And that basically keeps a record of like who your peers are and kind of like what their channel identifiers are, so that you can go to your peers, and then your peers can force close, and then they can force close in a way where you can get your money back as long as they cooperate with you. So we have those three components right now for how to like safeguard your funds.
What passphrase plus the seed?
What?
There is like a cipher seed on top of the pass.
Oh yeah, we also have a special thing. You're right. Which I don't use. So yeah. There's a feature that we have, which is yeah. Well, let's debate. The feature that we have with our seed is that, I guess, an LND. I don't know if it's part of the seed exactly. Is that we will encrypt the seed, like further encrypt the seed. I guess it is part of a seed. So you can provide a passphrase to your wallet. You can have your mnemonic, and then you also have a passphrase for your seed itself. So the passphrase for your wallet encrypts your wallet, and then the passphrase for, you have your seed, and then the passphrase for the seed encrypts the seed. And the big advantage, like the selling point of it, is like if you enter the wrong passphrase for the seed, it will tell you. It will say, hey, this doesn't match, and then potentially that will be better than trying to restore from a seed that you wrote down incorrectly, and you are like, where's my money? So you won't get to that state because you'll be stuck on the state which is like, what's my password for my seed? And it'll be like, oh, you got the wrong password for the seed. Instead of like loading up a seed and it's like, this is a random number, so I'm looking for all the coins on that random number. But I think there's like a checksum already in the seed, so I'm not sure. I personally don't use it.
Yes, it's not like an extra word then, or?
Yes.
It's kind of.
It's password. It's like,
yeah, but you kind of want it to be. It's hard to think about because if it encrypts the seed, like you don't want it to just be like Apple. But if you want to use it in the way which is like just checking yourself, then you kind of do want it to be Apple.
But could you restore without it, with just the seed?
No, you need that because you've encrypted the seed, yeah. So,
it's not like encrypting the file on disk. It's an actual component of the...
Yeah. You could store it in 2 different places maybe. Like if you did use it, what I would definitely recommend is you write down both. And our seeds are already pretty long. They're already 24 words. And then in order to make a passphrase with sufficient entropy to be meaningful, you need to make a long passphrase for that too. So you'd be writing a lot of stuff down. So that's why I personally don't use it. But other people, in different workflows, maybe it can be more useful. It really depends on like the situation.
Also, the Lightning app doesn't use it. Is that right?
No, the Lightning app doesn't use it. We have a PIN system, and the PIN system protects like a randomly generated like master password, but that password is encrypting the wallet. Yeah, and so if you do go through the recovery flow, it will just include and if you try to recover a wallet that does have it, then the app doesn't even support it. So
We had plenty of issues with the Raspberry Blitz builds because before the 1.2 version, which is the current one, we did offer this cipher seed option through the LND interface, and then people who did use it had trouble restoring because
it could cause problems, and it also doesn't work like the Trezor seed. The Trezor has a password, but the way that the Trezor password works is totally different. You have your master seed, and then the Trezor allows you to have special paths that are covered by just a simple passphrase maybe. And then the idea is you could show if somebody asked you to show them the money from the Trezor, you could show them one, and then you could be like, I only put in $100 there. All my rest of my money somewhere else. It doesn't work like that, although potentially it could. I also didn't mention the entropy. So entropy is now something that you can feed directly into the seed system. So let's say you're testing, I don't actually know. I wasn't privy to the conversations of why we need this exactly. So I'm kind of guessing. But for myself, I'd be if I want to run unit tests, I want that entropy to be reproducible. So every time I make a wallet, I get the same things out of it. And then I also know that as we're deploying to Android, iPhone, Mac, Linux, Windows, we're seeing a lot of variation in how entropy works on different platforms. Even though we use in theory, we're using React Native and stuff that's supposed to make the platforms all the same, but we're still seeing issues. So I think it probably ties into something like that.
I think I read that one of the motivations was to use the same entropy as the entropy used for your on-chain wallet.
It could be. I'm not sure. Let's say the entropy that was, well, in theory, your on-chain wallet would use, LND would use the same source of entropy for its own seed that it would use when it's, your on-chain wallet isn't separated.
Okay, so you have an on-chain wallet before you install Lightning or even install LND.
Oh yeah.
You have entropy on
I guess so.
And you want to use that same entropy in your LND wallet.
I don't exactly know why it was merged. It's been actually an open issue for a long time.
Because there is the complexity of the new seed format with versioning and birthday, AZ.
Well, that's not new.
But there's also the complexity of there being multiple key pairs required to monitor your channel, to monitor your on-chain funds.
But that's just how LND works. So we just use different key families within the same master key.
So the same source of entropy is feeding into those different key pairs.
Yeah, it's just like an HD key.
You've only got one source of entropy.
Yeah, so that's all deriving from that seed. So the seed had to be created with sufficient entropy, and it has 24 words, so there's going to be a lot of entropy there.
And where is the birthday stored?
It's also stored as part of the seed.
So it's derived from the seed.
That's why the seed is so long, is that it includes all this extra metadata. And so you don't have to write anything else down, but in order to make that work, we had to and also it's a little bit weird for people writing down the seed because they'll notice that the first word of an LND seed is always going to be A, because that's version 0. So they'll be like, oh, why am I always getting Atom as the first word or something?
I've seen that as an issue. And then, okay, so that's just intended to be like
Do old seeds migrate automatically?
I don't think we've actually changed the seeds. The only thing that we've added is the ability to add your own entropy in creating the seed. Maybe like in the olden days, we did change it one time. And we also didn't used to have seeds. So when I started using LND on mainnet, there was no seed. So unfortunately, I deleted that data, so I don't have one of the older nodes in the network, because I couldn't easily back up that state.
Then, if you're worried about the source of entropy, then you might be motivated to have different sources of entropy for, say, the key controlling on-chain transactions, the key controlling channel updates.
Well, with LND though, you're going to have this. It's going to be the same. So in LND, the same seed that is going to control all keys that are ever used. Yeah.
So
the thing that we could.
Yeah.
The thing that we might change is we have an on-chain wallet that is responsible for funding transactions, and also when you close the channel, it goes back to you. But we can offer more flexibility in that space, where we can say you can have your channel is funded by an outside wallet, and then the complexity there is because of the protocol, it has to be a SegWit spend. So, but as long as you have an external SegWit wallet, it can spend and create a channel externally from the application. That's something that we might add as part of Loop, because we want Loop, which is kind of like a separate application, to be able to tie back into the normal flows of the wallet. So we could say you could loop out, and you're looping out to a new channel. And then the other way as well. So if you close the channel, we could say that the output is something that is an externally controlled thing. And even the protocol itself, the Lightning protocol, has a feature that we've never used that we could use, which will set up like a predetermined exit address. And your peer will not allow you to change it. And the idea for that is let's say a hacker got access to your machine, they couldn't just close the channel out to their address. They would have to close it out to that current address, or they would have to have enough inbound liquidity to spend the channel down. And in that case, we could work on ways to even have policies that said you're not allowed to just spin the channel down unilaterally. You need some more checks or something.
Okay. Any other questions? Otherwise, I'll just ask one very last question. So you alluded to the Lightning Lab strategy of building out these services, but not necessarily wanting majority market share 5-10 years down the line. You're kind of building defaults, and you kind of want other people to come in and improve on them or build their own versions of those services. Because at the moment you're just doing so much, right?
Oh.
You're kind of a pioneer on Watchtowers, you're a pioneer on Loop in and Out, you're a pioneer on Lightning app and Lightning wallets. Are you planning longer term to go back and not be one of the major providers of those services, or are you happy with having majority market share providing all those different services?
Okay, yeah. So is Lightning Labs wanting to dominate the market of Lightning stuff? I would say actually we do want to dominate certain things. So we want to be your go-to liquidity provider when it comes to this Submarine Swaps type of thing. We want to at least provide a super compelling experience and be the best out there. So we're very committed to that. As far as apps go, I'm not on the app side of things, but I think our philosophy is more we want to provide a demonstration of a model of how the apps could be. And so I don't think we want to destroy all the other apps that are building apps on top of LND, but we do want to make a really competitive app that a lot of people are going to want to use.
Because we saw with
yeah.
Coinbase, when Coinbase got loads and loads of traction, it kind of
and
wound down a bunch of its different services.
Yeah. It is one thing we definitely are working on is to make things it's a side effect of our focus on being non-custodial for regulatory reasons, is that it also aligns with our philosophy that this should be a distributed network. And it also aligns with the whole idea of Lightning itself, which is like, why are we even using Lightning in Bitcoin? We're using it because we don't want to be locked in. So like, we should be aligned with that philosophy if we want to make Lightning a success. Otherwise, we're not providing something compelling. But you know, I don't run Lightning Labs. I'm not the CEO. So like, Elizabeth probably is the one to answer it.
We can cut that question out.
Yeah. Yeah, well, it's very commonly asked. Yeah, I can definitely tell you, like with Loop, we want to be number one loopers.